Hello, Algebra 2. Mr. Richardson coming at you here for notes on the quadratic formula. The quadratic formula is special in that you can solve any quadratic equation with the quadratic formula. So there aren't like different forms like factoring and finding the GCF or square rooting. All those can be solved using the quadratic formula. So why didn't we do the quadratic formula in the beginning? Well, because the quadratic formula is kind of long and involves a lot of math and a lot of kind of spots to make mistakes. So all those other methods are a little quicker, so they were worth learning because they saved us time and effort. But some quadratic equations cannot be square rooted, cannot be factored, and we need the quadratic formula to solve them. So there's a couple of problems here that are kind of backwards problems. So I'm going to do one of them, I think. I'll do A. I'm not sure if we're covering them this year, but I'll put them in the video. So it says, given the following zeros, or x-intercepts, write the quadratic in standard form. So basically what I do is I take them out of the solution mode, and I put them back in the factored mode. So if this is positive 2, it would have been negative 2, kind of equals 0. And if this is negative 3, that would be positive 3. And then I just multiply, so I get x squared plus 3x minus 2x minus 6, combine like terms. And I plug the y back in there for the 0. And again, I was foiling, sorry. All right, and so that's how you do it. You kind of it's just backwards from what we were doing, okay? And I'm not sure we're covering it, so if we are covering it, I'll come back and do those later. But for right now, we're going over the quadratic formula. So the quadratic formula is this. X equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. How you like that singing, huh? All right, so the quadratic formula obviously uses the coefficients of our quadratic, because remember, standard form is ax squared plus bx plus c. So as you can see, we're using the a, the b, and the c in the quadratic formula. Okay? All right, and the plus or minus sometimes throws students off, but the plus or minus is kind of the way you get the two solutions that we sometimes need when solving quadratics. If we cross the x-axis at two different spots, we need those two solutions, and the plus minus is what gets us there. So let's try number 3. So I'm just going to make it a little bit bigger so I see. So quadratic formula. So I'm just going to write down A is 2, B is negative 12, and C is 19. So I need the opposite of B. Why do I say opposite of B? Because it's not negative B. If B is negative, like it is here, I want the opposite of that, which is positive. So I got 12 plus or minus the square root of B squared. So I'm back to B. I always use parentheses in this spot. Always. Not sometimes, always. Times A, which is 2, times, let's see here, C, which is 19. All of that over 2 times A, which is 2. Okay? So, you can kind of see why the quadratic formula isn't the preferred method if we can do it another way, because it involves a lot of math. So, make sure you're using the old calculator here. I'm going to do what's underneath the radical here. So I get 12 plus or minus. I'm going to get my calculator out. Okay. I wish I could make it smaller or move it or something. That wasn't really. Oh, that's. Sorry, I don't know what's going on. Ah, that's bigger. Alright, I'm failing miserably, as you can see. But anyway, so I just want to move it over a little bit more. All right, I'm going to clear it. So here I go. I got parentheses, negative 12 squared. Where is this going? I don't know what just happened there. Sorry. Here we go. Clear. Parentheses, negative 12 squared. Minus 4 times A, which is, I believe, 2 times 19. All right, and it looks like I got -8. Okay, that's interesting. -8 there, and then over 4. So -8, if you recall, used to be no solution, but now it's going to give us a value of I. So what that means for right now is that when I graph this parabola, quadratic, it's not going to cross the x-axis, so my answers are going to be imaginary. So I have 12 plus or minus, I'm going to simplify this, so square root of -8 is square root of -1 times square root of 8. So that's square root of 4 times square root of 2. So that's 2i2. Remember that is I right there. So 2i square root of 2 over 4. And there's some reducing I can do there, but for now I'm just going to keep that as it is. All right, we're plugging 0 in for y. We know that. A is 1, B is -4, C is 5. So 4 plus or minus the square root of -4 squared minus 4 times 1 times 5, all over 2 times 1. So 4 plus or minus, I don't need the calculator, this is going to be 16 minus 20, all over 2. So 4 plus or minus square root of -4 over 2, another imaginary answer, but this one's kind of easier. So it's 4 plus or minus, again, square root of -4 is square root of -1, and the square root of 4, so that's 2i over 2. Again, there's some simplifying there, but you get that. My two solutions are there. Okay, so hopefully we get a couple that aren't imaginary, so we can kind of span the gamut. So I put 0 in there. A is -4, B is 1, C is -3. This one looks really ugly, so -1 plus or minus the square root of 1 squared minus 4 times A, which is -4, times C, which is -3, all over 2 times -4. Loving this. But you can kind of see that the quadratic formula does get long and mathy here. All right, what's under here? I'm going to need the calculator again. I'm going to shift. So it's 1 squared. So parentheses 1 squared minus 4 times -4 times, what was that last number there? -3 times -3. Ah, -47. We get another one that's imaginary. This is so much fun. So I get -1 plus or minus I square root of 47. I don't think can be simplified over -8, and that's my answer there. Plug in 0 here. A equals 8. B equals 6. C equals 5. -6 plus or minus the square root of 6 squared minus 4 times 8 times 5. Oh my gosh, I believe we have another imaginary. 2 times 8. Okay, -6 plus or minus what? So 6 squared minus 4 times, so that's 36. Minus 4 times 5 is 20. 28 is 100 minus 160. All over 16. Let's see. So 36 minus 160. -124. -6 plus or minus square root of -124. All over 16. And guess what we have? Again, we could simplify that. That's going to be another negative. It's going to be another imaginary. It doesn't cross the x-axis. And we are doing quite a bit of those. Okay, so here we don't have it equals 0, so we have to subtract the 11 from both sides. 0 equals 9x squared minus 6x minus 11. So A is 9, B is -6, C is -11. All right, I'm going to switch colors. Maybe that'll be good luck. Okay, so 6 plus or minus the square root of -6 squared minus 4 times 9 times -11. I'm guaranteeing this one's not imaginary. All right, so I need the calculator. 6 squared minus 4 times 9 times -11. So parentheses 6 squared minus 4 times 9 times -11. I am guaranteeing a positive answer. Whoa, 432! How you like them apples? All right. So 432. So 6 plus or minus square root of 432 over 18. Square root of 432. What the heck is that? We have to simplify that? Let's try it. Second square root 432 would be great if it was perfect square. No, it's not. Alright, so yeah, we'd have to simplify that. 432. Okay, and then the last one here that I'm going to do for now. Let's see, what's this page? Okay, this is the last one for now. I lost track where I'm at here. Going red again. So I have to subtract the x. Got to make that bigger. So I get 0 equals 10x squared minus x plus 9. A is 10. B is -1. C is 9. So 1 plus or minus the square root of -1 squared minus 4 times, this is 8, times 10 times 9, definitely going to be imaginary, over 2 times 10, which is 20. So let's see, 4 times 9 is 36, so 360. 1 minus 360 is -359. All right, so thank you. Again, simplify that. Those are 2 solutions. Thanks for following. You guys, good luck. Hope you do well.